Welcome to the paper training course. This course has 4 chapters. Click the name to jump to the desired chapter, or use the forward button to open Chapter 1. Chapter 1, Introduction.
Paper is the common factor between all our products, from original to copy, from fax to print, from A4 to wide format. Paper is available in many different formats, weights, surfaces, structures and color, all of which have an influence on the quality of the final deliverable. In addition, environmental changes have an influence on the paper characteristics over time. This tutorial will explain these characteristics in detail to help you and your customer to choose the right paper, sometimes referred to as media, for the job.
Chapter 2, Paper Characteristics.
Paper is available in many different formats, weights, surfaces, structures and color, each with its specific advantages and limitations, all having an influence on the final deliverable. In the offset industry, paper is selected per job, based on the requirements of the final deliverable, for example a book, magazine or calendar. In the general office market, paper is mainly, if not only, selected on its price. If the final deliverable is just a print of a document, the cheapest paper might be good enough. But when the final deliverable is a booklet or calendar, or when accurate colors become important, the cheapest paper will start to show its limitations. In such situations, the following paper characteristics are important. The surface, or smoothness, of paper influences the use of color as well as the readability. The structure, or grain, of paper influences the finishing, which might affect the image quality as well. The color, or whiteness, of the paper influences the color accuracy and readability. Paper is living material, sensitive to humidity changes and light. Paper absorbs and releases moisture into the air, causing it to curl and influencing its electrostatic characteristics. Light can affect the color of paper. Think about when a newspaper becomes yellowish in color. We therefore recommend storing paper in a dry and dark environment, sealed in its ream. Also, paper inside the paper tray of a device is affected by humidity changes. If the throughput is low, we recommend the customer to replenish the paper tray with less sheets and store the open package properly. The paper weight, or paper density, is an important specification for our devices. It is the concentration of paper fibers and other materials per sheet of paper. The higher the concentration, the more fibers, the heavier and stiffer the paper, the more difficult it is to bend. The curvature of the paper path of a device limits the maximum paper weight. Too heavy or too light paper can cause paper jams inside the device. The paper path is the combination of selected paper tray, duplex unit and finishing function. Especially the duplex unit can have a strong curvature, limiting the maximum paper weight for duplex jobs. Another limitation for the maximum paper weight is the fusing unit of a toner-based device. A combination of heat, pressure and the speed of the paper traveling through the fusing unit melts the toner and presses it into the fibers of the paper. If this combination is not optimal, the toner is melted incorrectly and this results in poor image quality. The user must change this combination by applying the correct paper weight settings on the device or in the printer driver. The paper weight is specified in grams per square meter or pounds, and can be found on the label of the paper ream. The most commonly used paper weights in the general office are 80 grams for black and white use and 100 grams for color use. Most devices support paper weight of 60 to 110 grams, but especially color and production printing devices supports higher paper weights. A higher paper weight might improve the quality of the document, where a lower weight might significantly reduce postage costs. When feeling the paper surface of a book, a newspaper and a glossy magazine, you will notice differences in the paper surface from rough to smooth. A rougher surface improves the readability of the document as the surrounding light is reflected in all directions and not only into the eye of the reader. It's best used for publications that demand long and uninterrupted attention from the reader, such as books and manuals. A smoother surface is more suitable for color reproduction or when very fine details are required, as the ink will stay on the paper surface and doesn't spread so much into the fibers of the paper. However, it will increase glare. The finish or level of smoothness of paper is determined during the production process. During the pressing stage, it passes through a series of rollers. The more rollers, the smoother and glossier the uncoated paper. The finish can significantly impact the image quality. If the surface is too rough, toner may not fuse properly and colors appear darker. Always use paper labeled as xerographic or laser imaging. To further improve the smoothness, layers of coating, usually china clay, are applied to the paper surface in an additional process. The clay acts as filler and the result is known as coated paper. The front and back side of a sheet of paper doesn't necessarily have the same structure. Higher densities in the fibers make the front side smoother. In addition, the higher density also causes the front side to expand more than the back side. The label on the ream of paper indicates the most preferred side. The arrow always points to the side that should receive the image or the first image in case of duplex printing. It's important to know the paper path of each paper tray in order to place paper correctly. Is white paper always white? Place different sheets of white paper next to each other and you will see differences. Because the white of the paper affects color accuracy, the whitest shiny paper might be ideal for true color reproduction. This type of paper produces more glares. It's not ideal for materials that demand long and uninterrupted attention, such as books and manuals. Off-white or a slightly warmer yellowish white might be better for such jobs. As paper is being made, its fibers generally align in one direction. Is the direction parallel to the long side of the sheet, it's called long grain or grain long. Is the direction parallel to the short side of the sheet, it's called short grain or grain short. A sheet of paper is stiffer along the direction of the grain, but bends easier across to the grain direction. When using thin paper, it's strongly recommended to place the paper grain in the same direction as the paper feed direction. As the paper is slightly stiffer in this direction, it easier separates from the drum surface and has fewer tendencies to buckle or bend, reducing the chance of paper jams. Standard paper is in general stiff enough in both directions. When folding is required, for example when creating booklets, make sure that the paper grain and fold are aligned. When you fold paper against the paper grain, the booklet will fall open. In addition, when folding against the paper grain, the paper fibers will crack, damaging the paper surface. The cracking of the fibers will also crack the coating of the paper and the toner layers on top of it, damaging the printed image. Special equipment, known as a paper creaser, is available to pre-fold printed paper, regardless of the paper grain. Environmental conditions are changing constantly. In these changing conditions, the paper fibers absorb and release the moisture in the air, causing them to expand and contract, curling the paper across the paper grain direction. This not only happens during the creation of the job, but also when the job has finished. For example, in order to prevent that a calendar, hanging above a heating unit, curls, use the correct paper grain direction. The grain direction is usually indicated by the second number in the dimension of the ream label. Other indications might be the word grain long or grain short on the label, an underscore or the letter M in the dimensions. The grain can be checked manually by scratching your nail along the sides of the sheet. A wrinkled edge means the fibers are damaged, a straight edge means the same direction of the fibers. Thick paper is best tested by bending it. One side offers considerable more resistance.
Chapter 3, Paper Sizes.
Paper comes in many different forms and sizes. The paper used in our devices can be divided into pre-cut paper and roll paper. Most of our devices use pre-cut paper. Roll paper is used in continuous feed devices such as our wide format devices and some of our production printing devices. Also, thermal paper fax devices use paper delivered on a roll. During the printing process, the roll paper is cut to the requested length. There have been many standard sizes of pre-cut paper at different times and in different countries, but in our business there are two widespread standards in use: the metric standard and the North American standard. The metric standard, also known as international standard and using millimeters as linear measure, is used throughout the world. The North American standard, using inches as linear measure, is primarily used in the USA and Canada. Our devices support both standards, as well as some country-specific paper sizes. The metric standard describes, among others, the following series. The A series describes the paper sizes from A0 to A10 and contains the most widely used paper format, A4. The B series describes the paper sizes from B0 to B10. It has been introduced to cover a wider paper range and fits between the A series. B4 is often used for newspaper, whereas B5 and B6 are used for books. The C series was designed to accommodate A series paper. A C4 envelope fits an A4 sheet without folding. The A series as well as the B series is based on an aspect ratio of the square root of 2. This aspect ratio makes it simple to scale a document for printing on another ISO paper format. If you divide an ISO sheet into two equal halves parallel to its shorter side, the halves will be the next smaller size in the series. This aspect ratio commonly appears on our copiers as preset magnification settings. 1 divided by the square root of 2 equals 71%, and the square root of 2 divided by 1 equals 141%. The base format of the A series is a sheet of paper which has an area of 1 squared meter. With an aspect ratio equal to V2, this sheet ends up being 841 times 1189 millimeters. An A0 sheet of 80 grams per square meter weighs 80 grams. Since 16 A4 sheets fit in one A0 sheet, one A4 sheet weighs 80 divided by 16 equals 5 grams. Most of our devices support paper sizes from A3 up to A6, which are the most frequently used paper sizes in the general office market. The smallest A sizes are not supported by any of our devices and the larger A sizes are only supported by our wide format devices. The base format of the B series is a sheet of paper with its shorter side measuring 1 meter and an aspect ratio equal to V2. Successive paper sizes in the series, B1, B2, B3, and so forth, are defined by having the preceding paper size parallel to its shorter side. While less common in office use, most of our devices support paper sizes from B4 to B6. The larger B sizes are only supported by our wide format devices. Many posters use B series paper or a close approximation, such as 50 by 70 centimeters. B4 is often used for newspapers and B5 is a relatively common choice for books. The C series was introduced to provide an envelope with enough space for an A series sheet. The sizes of the A series fit in C series envelopes of the same number. That is, a sheet of A4 easily fits into a C4 envelope. The consistent aspect ratio of the ISO papers makes it easy to fit larger paper sizes into smaller envelopes. This can be done by simply folding the larger papers in half until you reach the desired size. Another commonly used format is the DL format. A deciliter format envelope will accommodate an A4 sheet folded in thirds or an A5 sheet folded in half lengthwise. The uneven thickness of an envelope can cause image quality issues as well as wrinkled envelopes. It is for this reason that printing on envelopes is often only supported via the bypass tray or requires an envelope feeder unit to be installed in one of the paper trays. In addition, some devices require, next to the printer driver settings, a manual mechanical setting on the device to improve the image quality and reduce the chance of wrinkling. Many of our devices support printing on envelopes, but check for the requirements and precautions per individual device. Although not the standard within our region, you might receive documents with one of the following North American sizes. Letter, often abbreviated to LTR or LT, is the standard for business and academic documents and is similar to A4. Legal, often abbreviated to LG, is often used for writing pads. Tabloid and ledger have in fact the same size and are similar to A3. Tabloid is used for portrait-oriented documents, whereas ledger is used for landscape-oriented documents. Being double the size of letter, it sometimes is abbreviated as DLT. For technical drawings, another American paper standard is used. Also, this standard is primarily used in the USA and Canada. If you print or copy letter-size documents on A4 paper and vice versa, you might end up losing parts of the document. This may be at the sides or top and bottom of each page. In addition, the position of the image on the sheet of paper might be incorrect. Many printers offer automatic A4 to letter paper size conversion. This can result in a slightly shrunken image. To print or copy a lettered document on A4 paper, you should set the magnification factor to 97% since A4 is 3% less in the width. To print or copy an A4 document on letter paper, you should set the magnification factor to 94% since the letter format is 6% less in the height than A4. For most printer devices, the maximum printing area is slightly smaller than the maximum paper size. This prevents the user from printing full bleed, from edge to edge, and results in white margins at all edges of the sheet. Although this is no problem for the majority of office documents, full bleed printing can be a requirement, especially in the graphical industry. In such situations, the user can print on a larger paper size and cut back the printed sheet to the required size. To enable A3 size full bleed printing, some devices support paper sizes slightly larger than A3, yet smaller than B3, often indicated as A3 Plus support or SRA3 support. The term A3 Plus and A3++ is confusing in that it is no standard paper size. If you order A3 Plus paper, depending on the supplier, you might get different sizes. The term should only be used to indicate that the device can handle slightly larger than A3 paper, allowing the user to print A3 full bleed with crop marks, job info and/or color bars aside the actual image. But check the product details for the actual paper size. Frequently used real oversized A3 paper sizes are SRA3, 12 inches by 18, and 13 by 19. Is the segmentation of printers and MFPs often based on speed? The segmentation of digital duplicators is often based on the maximum printable area of its drum. Depending on the model, it supports an A3 drum, a B4 drum, or an A4 drum. The actual printable area is slightly smaller due to the white margin at all sides. Don't mix the printable area with the maximum paper size supported by the device. Some newer devices support A3 paper but their printable area is still B4 or even A4.
Chapter 4, Paper Folding.
Folding equipment can help the customer reduce postage and travel costs, improve fold accuracy and workflow efficiency whilst reducing manual labor. Online folding equipment enables the customer to print and fold direct mailers, letters, invoices and statements ready for insertion into envelopes, create menu cards, or add A3 size charts in an A4 size presentation. When folding is applied, think about the paper grain. Folding large format sizes, like architectural and engineering drawings, into smaller packets, makes it easier to store and cheaper to distribute. The similarity between existing fold styles is that all fold the original size back to an A4 size packet. The difference is the position and orientation of the drawing header. The following fold styles will be explained. DIN 824, DIN Special 210, DIN Special 297, Afner and Ericsson. DIN 824 is a fold style used to fold any landscape-oriented paper sizes with the legend in the right lower corner into a portrait-oriented A4 size packet. DIN 820, DIN Special 200. Most technical drawings are created in landscape direction with the drawing header, legend or title, in horizontal position in one of its corners. If the actual drawing should be looked at as if it was in portrait direction, like the Eiffel Tower in the example, the drawing header is vertical direction, making it difficult to read. The Association Française de Normalisation, which is the French national organization for standardization, has developed real Ericsson is a Swedish